Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So, from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now, to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now, I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front. And I have log 5 to the power of 2. So I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143. So I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right. Alright, so in this problem, I have 2 to the power of 22 times 3 to the power of 33. So to solve this, what I'm going to do is first rewrite 2 to the power of 22 as 2 to the power of 11 times 2. And now I have this times 3 to the power of 33. Well, 33 is, again, a multiple of 11. That's the same thing as 11 times 3. So this is equal to 2 to the power of 11 times 2 times 3 to the power of 11 times 3. Now, from here, there is an important property of exponents that I'm going to use to further develop this problem. So if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So basically, these two exponents simply multiply and result in a to the power of m times n. So 2 to the power of 11 times 2, what I'm going to do is I'm going to take this form and change it into this form. So 2 to the power of 11 times 2, I'm going to rewrite that as 2 to the power of 2 to the power of 11. And remember, this is also the same thing as 2 to the power of 11 to the power of 2. These two are the same because at the end of the day, they both are going to equal 2 to the power of 2 times 11. So now, I'm going to rewrite this as 2 to the power of 2 to the power of 11 times 3 to the power of 3 to the power of 11. So I did the same thing with 3 to the power of 11 times 3. Now, I'm actually going to simplify what's in the parentheses. So I have 2 squared in the parentheses, which is equal to 4 to the power of 11. And I have 3 to the power of 3 in the parentheses, which is equal to 27 to the power of 11. And now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So 4 to the power of 11 times 27 to the power of 11, this is equal to 4 times 27 to the power of 11. And now 4 times 27, that's going to equal 108. So now I have 108 to the power of 11. And this is my final equation, or sorry, not final solution to this problem.